Okay, I'd like to work through a problem that requires polynomial division. Here I've been given a rational function, so I have some fraction. The numerator is a polynomial, and the denominator is also a polynomial. And I've been asked to reduce this fraction, or reduce this rational function. When I go to set up my problem, I'm basically doing just regular old division. You might have seen this in grade school, but I'm going to be doing this problem with polynomials instead. So let me give myself a little extra room. My numerator was x to the fifth plus 2x cubed. I actually like to give myself some extra room, and I'm going to stick in a 0x to the fourth. It'll help me out later on. So there is my plus 2x cubed. There were no x squared, so I'll just put a placeholder of 0x squared. Take away x and plus 7. There was my numerator polynomial. Go ahead and put in the vinculum, is the name for that shape, but you don't need to memorize that. My denominator was x cubed plus 2x plus 1. Over here, I don't need, oh, there we are. Over here, I don't need the placeholder, so that's okay. I'm not going to put in the 0x squared here. Now what I'm going to do is I'm going to check the largest power of x I have over here, which is x cubed, and the largest power of x I have over here, which is x to the fifth. And I'm going to ask myself, what do I need to multiply x to the third by in order to get exactly x to the fifth? So here it's a pretty straightforward question. The answer is I'm missing an x squared. So I'll put an x squared up top. This is where I'm recording my quotient. And now I'm going to multiply this x squared by everything here in my denominator. And what do I get? X cubed by x squared is x to the 5. 2 times x by x squared is 2x cubed. So that's going to end up going here. So 2x cubed. And 1 by x squared is going to give me plus 1x squared. So yeah, there's a plus sign here. And you can see why I put this placeholder in. Everything lines up very nicely for the next step, which is subtraction. X to the fifth, take away x to the fifth is 0x to the fifth. That's nice. 0x to the fourth minus nothing is still 0x to the fourth. 2x cubed minus 2x cubed is going to be 0x cubed. That's looking very nice here. And now 0x squared, take away 1x squared is going to give me minus 1x squared. And I have to take down the rest of this here too. So I have a minus x. I'm not taking anything away from it, so that is still a minus x. And I have a plus 7. I'm not taking away anything from that, so I still have a plus 7. So that's the first iteration here. Now that I have done that, if I did it properly, the very largest x term that I have is gone. Right, I have 0x to the fifth. Let's just get rid of that. I have 0x to the fourth. I have 0x cubed. The largest term in this is now x squared. So I'm going to go again. I take the largest power of x I have over on the left. That's still x cubed. I take the largest power of x that I have underneath. Now that is x squared. If I get to a point where the largest power of x is smaller then x cubed, I stop. I'm done. I can't actually multiply any power of x here and get x squared, right? I can't multiply by an x and get a smaller exponent. So now I'm done. This was actually finished in a single step. Whatever you have up top when you're finished is the quotient. And whatever you have underneath is the remainder. So there are those. Let me return to my previous page. I needed to reduce this rational function. So I've just figured out that x to the fifth plus 2x cubed minus x plus 7 divided by the polynomial x cubed plus 2x plus 1 is equal to x squared with a remainder, and that remainder was minus x squared minus x plus 7. And since this was my remainder term, I'll have an x cubed plus 2x plus 1 as my denominator. So this would be the answer to this problem. One thing to notice here is that I started out with a rational function where the largest power of x was on the numerator. When I'm finished, here I've just got a polynomial, just a nice x squared. And that remainder term, I still have a rational function, but now the largest power of x is on the denominator. That's one of the ways that I have to check that I got the right answer.